Welcome to the AP Chem 2022 FRQ video series. Today we'll be solving question 7 of the 2022 AP Chem free response questions released by the College Board. Whenever a question pops up on the screen, please pause the video and read it to yourself. So for this question, we are given the Lewis dot diagram of the oxalate ion, and we're supposed to be identifying the hybridization of either carbon atom. So what I'm going to do is I'm going to choose this carbon atom. You can choose either one of them. You'll get the same answer. So for hybridization, we're going to be looking at electron domains. So that's what is going to give us our answer. So when I count, I see 1, 2, 3 electron domains. And 3 electron domains corresponds with sp2 hybridization. So that is our answer. One thing to note is that when you're doing electron domains, that's going to be either lone pairs or bonds. And a double bond counts as 1 electron domain. And it's just going to be either lone pairs or bonds that are touching the atom in question. It's the carbon atom over here. So now for part B, they're asking about KSP. They're asking the expression. So the first thing that you're supposed to do when you see this type of question is write the dissociation equation for whatever is in question. So this is silver oxalate. So the question we need to ask ourselves is, how would this dissociate? Well, by the subscript over here, I can tell that there's going to be 2 silver ions, and then that makes sense because the charge on the oxalate ion is 2 negatives, so that ends up balancing itself out. So now I have this dissociation equation, which can then in turn help me write the KSP, because now I know the coefficient for the silver ion. So now that's going to be squared. All right, so now the next subpart is molar solubility. So there's a complicated way you can go about this, and there's also an easier way. I prefer the easier way. It saves lots of time. So when we have something like silver oxalate, I see this as a 3-ion system. And the reason why I say that is just because I just count up the coefficients here in this dissociation equation. 2 + 1, 3, 3-ion system. So when it is a 3-ion system, the shortcut that we can use is KSP equals 4s cubed. So depending on whether it's a 1, 2, 3, 4, 5-ion system, there are different shortcuts that you can use, and you don't have to go through the complicated alternative procedure. So the KSP was already given to us, so I'm just going to plug that in. And we're solving for S, so that is what we're doing here. And then, of course, we're going to, cube root, all of that. You can do in the calculator, and then the value for S you will get is 1.05 times 10 to the negative 4 moles per liter. So now the next subpart talks about how this silver oxalate ion, how its solubility is increased when it is dissolved in perchloric acid. Now they want a net ionic equation, and they want a net ionic equation for the process that contributes to this increased solubility. You might be looking at this question like, how does the solubility increase? But you know what? They don't really want to know that. All they want is the net ionic equation. So they've already given you your reactants. Just go ahead. one important thing to note is in the previous parts we were dealing with solid, now it's aqueous because they're saying that the solubility is increasing. So you want to make sure that the state that you have it in here is aqueous. So now this is going to be like a double replacement reaction. And now what we need to do, very important step, is balance this equation. So I see Ag2, that tells me I need a coefficient to here to balance that out. I see an H2, and that tells me that I need a coefficient of 2 over here. So now the equation is balanced, and we can go on to writing the net ionic equation. So over here, this is going to dissociate into 2Ag plus aqueous, and then we're also going to have our oxalate. This is also getting dissociated. We're going to have 2H plus ions, and over here, this will also dissociate. One important thing to note is that this was a subscript, so it only belonged to the Ag. But over here, we had a coefficient, so that belonged to both of these ions. So you want to definitely watch out for that. And then over here is now the very interesting thing. This is what you have to realize to get the question right. So this over here, this is oxalic acid. Now, you may not know the chemical formula of oxalic acid off the top of your head, but you do know that this is not one of the acids that you memorized in your list of strong acids. So this has to be a weak acid. And because of it being a weak acid, it does not dissociate. So it stays just like that. And this is the key to getting the question right, because in my opinion, I feel that the rest of this part is doable as long as you can come to terms with that fact. So that's like integrating some acids and bases knowledge here. So now what we're going to do is we're going to cancel out the ions that are on either side. This goes away, this goes away. So now what we have remaining in the end, ultimately, is going to be the 2H plus ions and the oxalate ion that combine to form the weak acid. And that is our final answer. That's all for this video. Thank you for watching and good luck studying.